Welcome back to the blackboard once again. I'm going to continue on with the first order system lecture. And in this one, we are going to do two examples since the first one's relatively short. And so the first example is telling us to write the given system in the form of x, that's supposed to be a prime. X prime is equal to p of t of x times f of t. And so this is pretty much going back way back in linear algebra when we took a system of equations and put it into matrix form. So let's actually go ahead and get started. So to put this in matrix form, it's relatively simple. So this is just going to be a column vector of x prime and y prime, and this is going to be equaling to p t of x. So it's just pretty much every constant or variable with respect to t in front of x and y. So in this case, it will be 3, -2, 2, and 2 multiplied by x and y plus f of t. Because there is no constant, this would just be 0. So that was pretty much it. And then for the second example, it's the same thing. X prime, y prime is equaling to, because we have t, that doesn't really matter. We can just still put them in. So this would be t, and this would be negative e to the t, then it would be e to the negative t, and then t squared. Again, this is multiplied by x and y. And then this time, our f of t is this part right here. So this would be plus cosine of t, and then negative sine of t. And so that was it for this example. So that was pretty much it. It's not that hard. It's just the same thing as you've done in linear algebra, which if you're new to the series and new to the channel, I did a linear algebra playlist for this. So feel free to check it out if you want a quick little refresher. But let's actually go on to the main point, or the main example of the video. So this example, this one's kind of a little bit more work, and this is using the Wronskian. And we have to verify that the solutions that we find, quote unquote, are linearly dependent. So the reason why I put quotes on that is because the equation that they gave us, it already gives us a solution. So we have our solutions for this system of equation. And so this is our solutions, x1 and x2. And we have to figure out if they're linearly dependent or independent. And so to do that, we use the Wronskian determinant. And to find the determinant, we just, it's going to be the determinant of, the Wronskian is going to be the determinant of x1, x2, which these are column vectors. So our Wronskian for this case, it would just be 2e to the t, -3e to the t, e to the 2t, -e to the 2t. And so all we have to do is just find the determinant. And so this is a 2 by 2 matrix. And so finding the determinant won't be that hard. So this will be -3e to the 3t minus 2, that's a negative, so this will be plus 2e to the 3t, or e to the 3t, which is not equal to 0. So that means that the solutions are linearly independent. Solutions are linearly independent. Cool. So now for the second example and our last example, I guess part, for this video and pretty much this whole lecture is a 3 by 3 matrix. Oh, we love those, don't we? So same thing applies. We just find the Wronskian, or the determinant of the Wronskian, which would just be x1, x2, x3. Again, these are all column vectors, and we just plug it in. So this would be equal to 3e to the -2, -2e to the -2t. That's 2e to the -2t. This would be e to the t, -e to the t, e to the t, e to the 3t, -e to the 3t, and 0. And if you don't remember how to find the determinants of a 3 by 3, like I said, feel free to check out the linear algebra section. But we are going to use the square reduction, mostly because we have a 0 right here. So this is going to make our lives much more simpler. as we just have to find the determinant of two other things. So we're going to focus on the bottom row. So for the first one will be 2e to negative 2t. First one will be multiplied et to et, so it'll be negative e to the 4t minus plus will be negative e to the 4t, then minus e to the t times negative 3 e to the t minus plus 2e to the t, and then plus 0. So this part right here will go to 0, leaving us with negative e to the t times negative e to the t, or e to the 2t, which is not equaling to 0. Therefore, this gives us a solution that are linearly independent. And that's pretty much it for this video. I hope you guys enjoyed. Hope you guys learned something, make your life easier, and I'll see you guys in the next lecture.